Hello.
Hello.
Let's give everybody a few minutes to join us.
Sure.
Hey, Boone.
Yes.
Uh, remember we were working on this a document about SIP kits.
Huh?
Any chance you have the link? I can't. I have too many files, and right now I can't find it for some reason. I'm not sure.
Please wait.
Okay.
It's gonna be, Used to in um,
Oh, this is, we never created a document out of it. This is all captured in, in the, this
meeting
is
minute.
just in the meeting minutes. Okay. Yeah, that makes sense. Okay. So we'll need to create a new document for this. Okay. Let me do that right now then. Um, okay. So, okay. So here's my update. Here's a couple of updates for everybody on the call. The MDK and test design kit. I'm working in parallel in the background with OCP to get everything in the contribution database and reviewed by the server team. We have a meeting next Wednesday morning just to present to the server team what the contributions are about. So we'll see what feedback we get. So as far as TDK, test design kit was supposed to be next week. Next week is Chiplet Summit, so we're gonna have to skip that. So the next TDK meetings is gonna be basically 3 weeks from now. I expect that to be the last meeting, and the purpose for that is capture. Basically, the focus is focus on the test design kit paper and the feedback for it, implement it, and send the final version to OCP for publishing. The From there on, we are gonna see which way we go. Last time there were a couple of comments about things that maybe a good idea to add, so we may start working on TDK 2.0, or we may start work instead of TDK. We start work on package DRM, the ability to encode DRM rules into package and pa- package rules into the DRM. We just had a meeting earlier talking about the scope. So the scope for that will be anything that does not have active silicon devices on it is going to fall into that category. The reason being, obviously, that there's no common electronic version of package substrate rules right now. So we're going to capture that. And some of the newer technologies that are coming up, they do blur the line between silicon rules and organic substrate rules. So in terms of rules, they begin to look a lot like kind of a combination between silicon rules and your typical organic substrate rules. Some are more advanced, and some definitely do have rules which fall outside of the scope of what a PDK, silicon PDK has, right? So that's why the delineation is, does it have active devices or not? If it has active devices, that's your typical foundry silicon PDK. You would use that. Um, for everything else, basically you will have the option either, right, if the foundry has coded the rules in terms of like any silicon PDK, you can use that. Or if anything more advanced is necessary, any fancy rules, that would definitely fall into the category of package DRM. That's the if you remember one of my slides where I was describing PDK, I had called that a PDK, but the name PDK collides with the silicon PDK. So we're going to change that to PDRM, basically DRM kit. Maybe it should be package DRM kit, again, abbreviates to PDK, but anyway, we'll call it PDRM. Okay, so on the SIPA stuff, let me just walk briefly to what we have been discussed. Somehow I thought that we already have a document going, but I guess I was wrong. I probably was confused with the other two. So let me do like this. Some of the stuff we talked about is so the purpose of package SIPI design kit is twofold. What we want to do is capture overall we want to capture SIPI requirements for specifically for die-to-die IPs. And the purpose of that is instead of going to standards or IP PDF files, trying to extract the information, what are the voltage levels, where the voltage swing is, what is the half voltage, all that stuff, right? What the I should be, what are the data rates, what is the jitter that you're allowed, and so on, right? Instead of trying to do the PDF work, the idea is to encode that information into a file such that analysis and simulation tools can just read in that file and set up the simulation and the necessary checks, right? You will get a first cut setup in your simulation tool to allow you to do simulation, all right? And by doing that, the intent is to reduce errors, one. And second is you have the standard, right, which defines the boundaries for when an IP is operational and so on. I do expect that in reality, IPs to be a little bit different than that, right, than the standard. They will definitely operate within the standard, but they might do better. For example, in terms of speed, it is possible for an IP to go faster speed, right? And we have seen that with UCAE, where the standard defines some maximum speed. However, there's already vendors that are pushing beyond that and can do faster. Right, so the ability to describe the IP that's used on the chiplet in terms of actual IP, I think it's going to be invaluable. Right, so the data and the focus is mainly on die-to-die IPs. I think we would be able to capture SerDes, but SerDes is that's fairly standard, right? That's much simpler, I think, issue than die-to-die IP with its many pins. So what we have looked at is right properties of the IP in terms of what are the encodings, what are the clock rates, what is the clock mismatch, I diagram limits, data skew, bit skew, or word and byte skew, right? There's some standards have different requirements about that. Driver impedance, voltages, and then you see, right, for example, for UCE probably modeling, that would be a good example, right, with its modes, single direction and bidirectional, especially with bow memory that's bidirectional that's coming up. That would be interesting to understand, and so on, right? I think there's that's about it. Check out the minutes. I thought incorrectly. I apologize for that. That today we can start. We're going to work on the actual specification, but apparently we don't have one. So uh, I'm going to take the action to put all the stuff we talked about, put it in a spec, so that in 2 weeks we can review first cut spec and see what's captured, what's not, what's missing. Right. I would suggest as a first first cut, go to the meeting minutes, please, and see what we have talked about in terms of SAPI, what needs to be captured. And we can start coding, creating a specification that captures all this data. Of interest to me is provide me feedback if any data is missing that you would like to capture, but we do not.
David,
Yes.
sorry to interrupt. Can I get a link for this document? I know I've seen this document. It's just that there are so many documents over there. If you can send link, direct access, that would be nice. That's all.
So the this is always in the meeting invite. I keep the meeting minutes there. So you have the meeting invite from this calendar, right? So if you go to
Yes, I do.
yeah, okay. So this is
Okay.
the document.
Okay, I got
Or also you can browse the CDX folder and see what's in it.
Okay. Okay, I can do that. Yeah, thank you.
Yeah. What else? Is anybody is anybody joining the Chiplet Summit this year? I know Boone, you're far to join. How about others? Mohammed, Vikas, have you planned to visit Chiplet Summit this
No,
year?
unfortunately, I won't be able to make it.
Okay. Do you know from Siemens who will be at the summit? Is Tony going to be there?
Pratush will be there. I know
Oh,
Pratush will
Pratyush.
be there.
Yeah, Pratyush has. Yeah, me and him have a tutorial. Actually, he's
Yeah.
running a tutorial. Just okay. I'm just helping. All right. Okay. Well, okay. So I don't have anything else. Apparently, I have developed false memory that we have the SIPI document, but that's me thinking about the other specifications that we are contributing. So I don't have anything else right now. How about you guys? What else is on your minds for today? Okay. Does that mean nothing? I guess it does. All right. So let's reconvene in 2 weeks. As soon as I start up the document, I'll try to create the document before the meeting. As soon as I start it and I populate with some stuff, I will send it out to the mailing list, and you guys can take a look at what I have captured and what I'm missing. Okay. Next week is Chiplet Summit, so probably by around the end of next week, or early next week, the week after, expect email from me about the SAP document.
So, David, one question. So, the document for SAPI you are talking about, that is the electrical specs for die to die?
Yes.
I see.
Not
So, it
on
doesn't.
right. So what we want to do is we at high level, we want to encode the electricals of a chiplet, right? The electricals which you would typically find in a PDF datasheet. We want to encode those into a machine readable format file, right?
Mhm.
That I wanted. I'm splitting here with my answer here, probably giving you a longer answer than what you're looking for. But in terms of electricals, right, there is two ways to describe electrical. One is you have the standard, right? Take BO or UC, right? That says, hey, here is BO and here is what the standard mandates, right? And in that case, at the minimum case, what I expect from people to come and say, hey, these pins here, this interface here is a BO, right? And it's running at this much speed, right? And here is this definitions from the standard. Right. So when you are running simulation, your tools would read that and should be able to automatically set up your simulation environment in terms of drivers and in terms of signal integrity checks. Right. Now, the fine grain in here is that when IPs do better than a standard, actually, that they might do worse for all practical purposes, right? When they deviate from that, a provider would be able to come in and say, "Hey, here's the actual parameters on my IP, on that IP that's on my chiplet, right?" And you can use those for simulation instead of the standard ones, right? For example, any transmit IP, right, would have the standard would define limits on jitter, which an IP might do better for practical purposes, right? And people should be able to take advantage of that. And when it does worse, if it still works on both sides, okay, right? That's fine too, I guess. But it's important for cases where the IPs on both sides of when two chiplets, right, on both sides have slightly different parameters, right? The simulation would need to be able to tell us whether that works or not.
Okay. Okay.
Did I answer your question with my long answer?
Yes, I did. I was just thinking, like, does it have anything related to material itself? But apparently it's just mainly, SIPI electrical specification.
It's only
Yeah.
it's only electrical specification. Material definition comes from two places, right? One is the material the design kit will already have the parameters for all materials. All the right should have all the
It
parameters for you to do
actually
SIPI,
has.
right?
Yeah.
And then
Actually, MDK has everything in it with all the thermal compression, TCV, everything. So if you
right.
go over that, yeah.
And then the second piece of information which you would need is a layout, which tells you, hey, this is the stack up, these are the objects, and
Mhm.
you assign the materials to those, and then you run extraction simulation.
Hello, David. Hello.
Hey, Ching.
Oh, sorry. Yeah, I just got a new laptop, so I just struggle with the microphone.
Oh, okay.
Good. Now it works. Okay, thank you.
We can hear you.
Okay. By the way, I have a very quick question. Do we have tomorrow's meeting, Friday?
No, we don't.
Okay.
I think I canceled it.
Okay, great. Thank you.
Oh, actually, I haven't canceled it, huh? I was thinking of canceling it. I will cancel it. Oh, thank you for reminding me. I need to thank you for your question. I'm glad your microphone is working now.
Yeah.
That was important. I would have missed it. Thank you.
Yeah. Just cancel, yeah, if you can. Yeah.
Yeah,
Thanks.
yeah. Okay. And congratulations on your new laptop. Hope it works
Every
good.
4 years we get new laptop here. Yeah.
Mm.
Yeah. Okay.
Nice. All right. Any other questions?
Not from my side. Yeah, thank you.
All right. Then let's reconvene in 2 weeks and
I can.
get that specification going. All right. So thank you, everyone,
Okay.
and have a good one.
Thank you.
Bye bye.